My name is Angus Wallace, and I would like to introduce RedBrick, my LEGO-inspired PiWars robot. I've been involved in PiWars since 2017 as part of my family team. We made the Glitterator series, all LEGO based, including LEGO motors, which work really well with the RaspberryPi motor driver boards. One of the problems with LEGO is that it does come apart rather easily, but it can also be quickly reassembled. In 2018, we used the popular Rock Candy wireless controller. It worked great in testing, but at the event we had problems with the wrong controller pairing with our robot. We used a different controller the next year. In 2019, I had learned enough Python to write the code for our team's line-following attempt. It used the camera and OpenCV libraries. RedBrick still uses LEGO motors and wheels, and the attachments are constructed with LEGO Technics components. But at the core, it is a modified LEGO money box. Inside the box are the battery, RaspberryPi 3A Plus, and motor driver. The box clips onto the chassis and the motors and lights plug into it. The motors and lights use standard LEGO wiring components. Extension cables have been modified to connect to the motor driver board and the GPIO pins for the lights. This means I can run the Pi and connect or disconnect these items as needed. The overall colour scheme is red, black and yellow, following the LEGO logo colours. The robot has some LED strips added for each track, which strobe to reflect the speed and direction of travel. When running in remote control mode, I can also adjust the sensitivity of the controller, adjusting the maximum motor speed downwards for more fine control. The lights flash as I adjust this control. The core robot is extremely sturdy, and the addition of some flippers means I can even use the remote control to recover from flipping. This works just as well in the wild. I have different attachments for the different challenges. For Up the Garden Path, a camera is used to detect the line, and a re-speaker hat for the voice control. For Feed the Fish, I have a motorized catapult that flings 5 pieces of food at once. That motor is simply switched on or off using a single pin on the Pi. For Tidy Up the Toys, a servo is used to make a gripper, and one of the servos that I use for the flippers is extended to lift and stack the blocks. For the code, I have kept it as simple as possible to minimize the amount of processing on the Pi. For example, I used to choose the direction by first finding the defects in the convex hull of the shape. Then I would join these, and from this see the 2 new line segments. Then I would find the middle of these line segments, and follow those. In the new version, I just find the leftmost or rightmost point in the field of vision. I hope you've enjoyed learning about RedBrick.